The instructions for use are the information provided by a medical device manufacturer to inform the patient of the device's intended purpose, proper use, and of any precautions to be taken. The intended use is the use for which a product, process, or service, in our context, a medical device, is intended, according to the specifications, instructions, and information provided by the manufacturer. The intended medical purpose is the use for which a device is intended according to the data supplied by the manufacturer on the label, in the instructions for use, or in promotional or sales materials. A reasonably foreseeable misuse is the use, intentional or unintentional, of a product or system in a way not intended by the manufacturer, but which can result from readily predictable human behavior. Risk is the combination of the probability of occurrence of harm and the severity of that harm. Risk revolves around these two questions. Based on the probability of B happening, we will choose whether or not to take action A. Risk can be viewed as a delicate balance of benefit versus cost. In the context of medical device risk management, cost is defined as injury or damage to health. It is important to know that risk cannot be eliminated. In the real world, there is no zero risk. Risk can only be managed if you reduce the probability of it happening. Next, let's take a look at how the device manufacturer should compile a list of known and foreseeable hazards in normal and faulty situations. The manufacturer should also consider the foreseeable sequence of events that can produce hazardous situations and harm. The risk can be assessed by estimating the severity and probability of occurrence of the potential harm. The conclusion of this flowchart is that a hazard can lead to multiple hazardous situations. Each situation can lead to multiple harms. The probability of occurrence of harm can be composed of separate P1 and P2 values. Thin arrows represent elements of risk analysis. Thick arrows represent how a hazard can lead to harm. Risk management is the systematic application of management policies, procedures, and practices to the tasks of analyzing, evaluating, controlling, and monitoring risk. It means that the quality management system of your organization will need to have a risk management procedure that describes on a high level how risk will be managed. It should describe the criteria, types of medical devices, action types to reduce risk, and any other relevant details. Risk assessment is the overall process comprising a risk analysis and a risk evaluation. Risk analysis is the systematic procedure to use available information to identify hazards and to estimate the risk. Risk estimation is the process used to assign values to the probability of occurrence of harm and the severity of that harm. Risk evaluation is the process of the estimated risk against given risk criteria to determine the acceptability of the risk. Risk control is the process of making decisions and implementing measures to reduce risk. Safety, from a risk management perspective, is freedom from unacceptable risk. Safety and safe should not be used as adjectives to avoid the misinterpretation of assurance of freedom of risk. For example, a safety helmet can be misleading for a person who thinks that the helmet will protect them from all head injuries. It is important to understand that any medical device carries a certain amount of residual risk. All users should be aware of such residual risks. Residual risk is the risk remaining after risk reduction measures have been implemented to avoid or limit potential harm. For a patient to receive harm, the patient must be exposed to one or more hazards. Logically, hazards appear before any harm is caused. Note that all hazards represent a potential source of harm. ISO 14971 provides a neatly organized table in Annex C that classifies hazards. I recommend that you use it to define your own master table of hazards for your company. Energy hazards: electric energy, acoustic energy, mechanical energy, potential energy, radiation energy, and thermal energy. Biological and chemical hazards: biological agents, chemical agents, immunological agents. For example, infections may occur if the medical device has been inadequately decontaminated after use. Performance-related hazards: data, delivery, diagnostic information, and functionality. For example, inaccurate information in the instructions for use or advertisements. Risks need to be measurable. Simply knowing there is a risk of harm in a medical device is not useful. Quantitative data of risk is preferable over qualitative findings. However, in the absence of quantitative data, qualitative findings should be measured. Important: do not confuse the meaning of harm with the meaning of risk. These terms are not interchangeable. That's all. Thank you for attending this course. I hope you found it useful and that you have learned what you expected. See you in other courses at Scilife Academy to continue your learning journey.